Hey, this is Mr. Janes. In this video, we're going to be talking about how to divide radicals and what rationalizing the denominator means. So far, we've talked about how to add and subtract radicals. We've also talked about how to multiply radicals, but we've never talked about how to divide radicals. So this video will be devoted to talking about how to divide radicals. But first, let's do a little bit of review. Questions 1, 2, 3, and 4 all deal with adding, subtracting, and multiplying radicals. You should pause the video here and attempt questions 1, 2, 3, and 4. Then unpause the video to see me do the problems and make sure you have the right solution. So pause the video now. Okay, let's start with number 1, 2, 3, and 4. So for number 1, we are adding and subtracting radicals. And remember, we can only add and subtract radicals that have like numbers under the radical. Remember, combine like terms. So when I look at this, I see radical 6, I see radical 6, I see a radical 5, and I see a radical 2. And that means that I can only combine these first two terms because they both have radical 6. So negative 3 minus 2, that will give me negative 5 radical 6. I've got a plus 2 radical 5, can't combine that with anything else, and a minus radical 2. And that's all I can do. Remember, I can't combine any of these terms because they don't have any more like numbers under the radical. So I'm done. For number 2, sometimes you've got to simplify your radicals before you can add them together. So we look at number 2, and we have 2 radical 2. Now, radical 2 can't be simplified at all. It's a prime number, so I'll just write that down here as 2 radical 2. But radical 8 can't be simplified. It breaks into 4 and 2, and 4 breaks into 2 and 2. So it looks like we've got a pair of 2's and a lonely 2, which means that 3 radical 8 is the same as 3 times 2 radical 2. Or 3 times 2 is 6, 6 radical 2. Okay, and then the square root of 24 breaks down to 4 and 6. 4 goes into 2 and 2, and 6 breaks into 2 and 3. So it looks like we've got a pair of 2's, a lonely 3, and a lonely 2. So I already had a 2 outside that radical, times the pair, okay, square root, the lonely 2, and the lonely 3. So 2 times 2 is 4, and 2 times 3 is 6. So now I've got 2 radical 2, 6 radical 2, and 4 radical 6. And so I can combine the first two terms, 2 radical 2 plus 6 radical 2, leaves us with 8 radical 2. But I can't add on that 4 radical 6 because it doesn't have the same number under the radical. This has a 6, this has a 2, can't combine them. So we leave it as 8 radical 2 plus 4 radical 6. We've also talked about how we can multiply radicals. Let's look at number 3. Remember, multiply the inside of the radical together, multiply the outsides of the radical together separately. So we've got radical 10 times radical 2. That's going to be radical 20, square root of 20. And now we can simplify it. 20 breaks down into 10 and 2. 10 breaks down into 5 and 2. Looks like we've got a pair of 2's and a lonely 5. So the square root of 20, that's going to be 2 radical 5. Right. For number 4, similar setup. We have a 3 times a negative 5. 3 times negative 5 is negative 15. Okay. Radical 25 times 5. Let's see. Oops. Got 125. Okay. And now let's see if we can simplify that a little more. 125 breaks down into 25 and 5. 25 breaks down into 5 and 5. Looks like we've got ourselves a pair of 5's and a lonely 5. So we have negative 15 outside the square root times that 5 from the pair, square root of 5, and 15 times 5 gives us negative 75 square root of 5. All right, we're all set with reviewing how to add, subtract, and multiply radicals. So it's time for something new. How do we divide radicals? Well, it's a lot like multiplying radicals. Look back to question 4, where we multiplied 2 radicals together. In question 4, we multiplied the numbers on the outside of each radical, the 3 and the negative 5, and we multiplied the numbers on the inside of each radical, the 25 and the 5. Well, it's going to be pretty similar with dividing radicals. If you look at question 5, we've got a square root of 15 divided by a square root of 3. Now we can actually divide the two numbers inside the square root. So we can do the square root of 15 over 3. Okay, so what's 15 divided by 3? Well, 15 divided by 3 is 5. So that's just the square root of 5. That's your answer, the square root of 5. We can do a similar thing for 6. Right? We can divide the numbers on the outside of the square root, 4 divided by 4. And we can divide the numbers on the inside of the square root, the 6 divided by 3. 4 divided by 4, well, it's just 1. And 6 divided by 3, well, that's just 2. So we're left with 1 times the square root of 2, or we can write that as just the square root of 2. But sometimes we're going to have issues when we divide like that. Look at something like number 7. That's 3 over the square root of 5. There's no radical on the top. How are we going to divide that? Or look at something like number 9. There's a radical on the top and the bottom, but 6 doesn't go into 10. So how do we divide those? Well, we have an answer for that. We're going to do something called rationalizing the denominator. Okay? In math, we don't like to have a square root in the bottom of a fraction. We don't like to have an irrational number in the denominator of a fraction. So the square root of 5 right there, that's not good. We don't want that there. In number 9, the square root of 10, we don't want that there either. We need to somehow figure out a way to make it so that there are no square roots in the denominator of our fractions. Here's what we're going to do to fix that. Look at number 7 first. Okay? What we're going to do is multiply both the top and the bottom by the square root of 5. Okay? We're going to multiply the top and the bottom by this radical in our denominator. Now it's okay that we multiply the top and the bottom by the square root of 5 as long as we multiply both the top and the bottom by the same thing. So we get 3 times the square root of 5 is 3 square root of 5. And square root of 5 times the square root of 5 is the square root of 25. And we know that the square root of 25 is just 5, so we could write this as 3 square root of 5 over 5. And look, we started with a square root in our denominator, but we've ended with no square roots in our denominator. And that's called rationalizing the denominator. Go ahead, pause the video, and try to rationalize the denominator in number 8. Okay, let's see how it's done. So we need to get rid of the square root of 2. We can't have that in the denominator. So we multiply the top and the bottom by the square root of 2. On the top we get 3 square root of 2. And on the bottom we get the square root of 2 times the square root of 2 is the square root of 4. But we know that the square root of 4 is just 2, so we're left with 3 square root of 2 over 2. And we're done. We've rationalized the denominator. There are no more radicals in the denominator. Let's go ahead and look at number 9. It's a little trickier. Looking at number 9, we've got this square root of 10 right here, and we don't want that square root of 10 in the denominator, right? That's one of our rules. So we're going to multiply both the top and the bottom by the square root of 10. Okay. And let's see what we get. 3 root 6 times the square root of 10 gives us 3 square root 60. On the bottom, 4 square root 10 times square root 10 gives us 4 square root 100. At this point, we should probably try and simplify both the top and the bottom. So let me do that separately. The numerator is 3 root 60. 60 breaks into 10 and 6. 6 breaks into 2 and 3. And 10 breaks into 5 and 2. So it looks like we've got a pair of 2's, a lonely 3, and a lonely 5. So the square root of 60, let's see, the 3 from before, the 2 from the pair, and inside the radical will be the 5 and the 3, which gives us 6 radical 15. So that means that our numerator is really 6 radical 15, right? And then the denominator, well, 4, put it over here, 4 square root 100, well, that's just 4 times 10, which is 40. So our denominator here is going to be 40. Okay. Now, looks like we're done. There are no radicals in our denominator. We've successfully rationalized the denominator. But technically, we could simplify this a little more. 6 over 40. Yeah, we could simplify that to be 3 root 15 over 20. Okay, and that is in simplest form now, right? Our fraction is in simplest form, and we've rationalized the denominator. So, go ahead, pause the video here, and try number 10. Alright, so here's the answer to number 10. Let's see. I've got the square root of 5 in the bottom of my fraction, and I need to get rid of that. So I'm going to multiply both the top and the bottom by the square root of 5. Okay. My numerator becomes 3 square root of 5. My denominator becomes 2 square root 25. And let's see. We know that the square root of 25 is 5, so this is really 2 times 5, or 10. On the top, we've got 3 square root 5. There's nothing left to simplify. I can't reduce my fraction anymore, and there's no more radical in my denominator. So we've successfully rationalized the denominator for number 10. Sounds good. So hopefully you've learned how to divide radicals by rationalizing the denominator. Go ahead, try the homework problems, and you can ask your classmates if you have questions or come see me after school. Good luck!